Now we're going to do a case study of a building energy model. So first we're going to sign into Sketchbox. Now the project that we're going to be looking at is a library building, new building that's proposed in Sun Prairie, Wisconsin. The links to these documents are going to be available in the video description, but this is currently in concept design stage, so very preliminary, but you can see there's a site plan in these documents, there's a rough floor layout, some details about the building, a more detailed floor layout, and there's also some budgetary information provided, as well as some renderings of the proposed building. Now, this project is an expansion of an existing building, so in addition to these plans, I've also got a photo of the existing library pulled up just to give us an idea of what this structure looks like today. The other thing to note is that even though this is a major renovation and an expansion, the current mechanical systems, so heating, cooling, hot water, etc., in the existing building are nearing end of life. So all of those systems will be completely replaced for the new building. So we don't need to consider the existing infrastructure at that building other than the layout of the space. So to get started on the project tab here, we're going to give this project a name. And as I mentioned, it is located in the state of Wisconsin. The nearest city for reference here is going to be Madison. Now for the energy code, the city is committed to using the latest version of the energy code, which the latest that we have right now in Sketchbox is IECC 2018, so that's what we'll stick with. In terms of compliance path, we're going to stick with the default of efficient lighting system. This tends to show the most significant savings, and that's what we're interested in here. But as an additional exercise, you could change the compliance paths and see what the impact on the total energy savings would be. In financial and emissions, we're not going to make any changes here. This is a commercial building for billing purposes, and we'll stick with the default rates for electric, natural gas, carbon, and carbon emissions. Next, we'll go over to the Design tab, and this is where we're going to spend most of our time today. So before we do anything here, however, I want to make a copy of this. We're going to save this project where we're at, and we're going to do that a few times as we're going along just to make sure that we don't lose our work. So first thing we'll do is change the shell type. It's not an office. This is going to be a library. Nothing else we need to change there. Now, square footage is a key number. If we look at our documents, we can see the site plan here. Tells us that the total square footage after expansion will be 65,000 square feet. So we'll punch that in. All right, now aspect ratio is an interesting one. If we hover the mouse over aspect ratio, we'll get a little pop-up that tells us that this is the ratio of the building defined as the length in the east-west direction divided by the length in the north-south direction. So how can we get that? Well, let's go to the floor plan here in this PDF document, and there's one that is square on, and Adobe Reader has a measurement tool which we can use. So we're going to open that, and again the units here don't matter because we are interested in the ratio, not the actual values. So we'll use our measuring tool. Roughly from east to west, we've got, let's see what that is, 8.38 inches. And then roughly from north to south, let's see, where we'll pick an area that's kind of halfway in between the widest and the narrowest. So right about here. 4.78 inches. Put that right there. Okay, now see, I've already forgotten which direction we're dividing. We want the east-west divided by the north-south. So switch back over to the drawing and open a calculator. We're going to do 8.38 divided by 4.78. We get a value of 1.75 for that ratio. So we'll punch that in here, and you can see the building will change to reflect more or less the shape that we saw in those drawings. Now you also notice from the site plan here that the building is not facing directly north-south, which is the way we've currently got it indicated. So we're going to need to change that orientation. We can do a rough calculation. This looks like roughly a 45-degree rotation. So if we go back here, we can change that in the site input. So we're going to change the site orientation to 45 degrees. And now, oh, that wasn't quite right. Looks like we want to go the other way. So we'll put in minus 45 degrees. There we go. So you can see that more or less lines up with the orientation of the building there. All right, now's a good time to save. I'm going to hit that save button. It's going to be overwritten. That's okay. We'll save the project. Okay, we know that there is only one floor to this building, so we'll leave that the way it is. Now, what about the floor height? We can look at the rendering here. If we go to page 11, and we'll use a common trick that we use to figure out the height of this building. We'll take a look at this door here. Doors have a standard height of 80 inches, which is just under 7 feet. And we can kind of see visually that if we stacked up 2 of those doors, that would get us the full height of the building. So we're going to say, and we don't really know what's going on in this area up here. It looks like it might be an attic, but it's unclear whether or not the insulated area ends here or higher up. So we're going to go with an estimate of 14 feet total ceiling height inside the building. All right, the next value is perimeter zone depth, and I'll talk a little bit about why this is important, but we're not actually going to make any change here. When a mechanical system for larger buildings, so larger than a house, really, are designed, they need to consider the heating and cooling needs of the perimeters of the building, which are exposed to these walls that are going to be hit with sunlight or cold air in the winter, compared to the core of the building, which in many buildings, especially larger buildings, the core is never going to need heat because there's so many internal heat sources from lighting, plug load equipment, people inside the space, that actually cooling may always be needed in those interior spaces. So 15 feet as a perimeter zone depth, which is the depth of that zone around the outside of the building, is a pretty good assumption, so we're going to leave that here. But again, it can be interesting to change that number and see what the impact on the energy usage is. Now, roof type, it sort of looks like there's an attic in this building, but actually if we go to that rendering again, or if we go to the layout, what that looks like back on page 3. Oh, we still got our measuring tool open. Let's go back to our hand tool. All right, if you look at the roof of that building, you can see that that sort of attic structure is mostly just decorative around the outside of the building, and there's actually a flat roof in most of these spaces. So what that tells us is the type of roof we want to select is this default of insulation entirely above deck. That means there's a flat deck and insulating material applied above that deck surface for the building. Now, wall type. Here we've got 4 different choices: mass, metal building, metal framed, wood framed, and other. We won't go into detail on what these are, but this is a mass type wall, and you can tell because this is a brick and stone wall. Now, glazing type, our 2 choices are fixed fenestration or operable fenestration. This is a fancy way of saying, can you open the windows or not? Typically in a commercial building, we would see fixed fenestration. It's unlikely that the windows would be operable, and even if they were, they wouldn't typically be opened by anyone in the building. So we're going to choose fixed fenestration here. Next, we have window to wall ratio, and this is important because the more glass there is in a building, the more impact sunlight will have on heating that building. So we need to choose this value carefully. The standard assumption is 40%. So by default, the program is assuming that a library is going to have a window to wall ratio of 40%. So 40% of the surface is composed of glass. However, if we look at the picture here of the existing building, we can see that there's quite a bit less than 40% of that face. This is the main entrance to the building, is glass. And then if we look at these renderings, jump to page 11, zoom out a little bit, we can see that while there's a fair amount of glass on this surface here and then on the back side of the building as well, most of the rest of the building is a mix of solid wall and glass. So 40% is probably too large of an assumption for window to wall ratio there. We're going to change that to 30%. All right, we're going to skip over a few things here. There are some small skylights in this building. We're not going to model those right now. Let's take a look at the heating fuel type. So here the City of Sun Prairie is interested in having a fully electric building in an effort to be net zero ready. So we're going to change the heating fuel type to electricity. Now the air side system is the part of the heating system that is actually delivering heating or cooling to the spaces. So it's not where the heating and cooling is made, it's how it's delivered. And we're going to pick packaged heat pumps, and the reason for that is that we actually want to model ground source heat pumps. And a ground source heat pump as the cooling source is compatible with packaged heat pumps. Now when we made that change, you see that there's a warning that popped up. So when we're using heat pumps, the cooling and the heating systems have to be the same type. So make sure we change this to ground source heat pump as well, and then that error goes away. Next is dedicated outdoor air system. So a DOAS is the part of the building that is responsible for bringing fresh air into the space. So we're going to choose the DOAS system to use the same heating and cooling source as the primary HVAC system. So that those ground source heat pumps will provide the heating and cooling for the outdoor air system as well. And we won't make any change to the electric resistance heater, and water consumption, we'll stick with the defaults there. And over on the Site tab, we're not going to make any other changes here besides the orientation, which we've already done. So now's a good spot to save our progress. And in the next video, we'll take a look at the Schedules and Baseline tabs.